Okay, the logic is if theta I is bigger than critical angle, then trace wave number has to be this big, right? And that cannot be made by using this circle, right? Right? So the next step is then maybe theta t has an imaginary part. And I propose you guys to think about it. But if you accept that the theta t has imaginary part, there is a wave exponentially decaying in x direction. Okay? Then I will go actually on that topic later on, of course, when I explain the waves on the plate. It's not, but so let's raise that question at this lecture. Okay.
Is the wave in the medium one still plane wave?
Plane wave, yeah. But obliquely instant. Obliquely instant. Okay. Okay. But there are many different okay, right? Okay. 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 But your okay is very okay with a lot of uncertainties. You still have many questions. So those questions will be explained in detail in next lecture, but let's think about it, okay? And the other one, I can say the pressure continuity. Let's start with the pressure continuity on x equals 0. Then I have component of y, component of y, component of y, that has to be same, and omega t, so everything is same. So I can come up with the famous pressure continuity, simply P I complex magnitude P R has to be same as PT. Wow. What is the velocity due to instant wave? That is Pi divided by characteristic impedance of medium 0, that is rho 0 C 0. And the velocity in x direction has pi exponential j omega t minus the component in x direction on x equals 0 has only ki y. Y, that is what? K0 sine theta 0, right? So I have over here sine theta 0, right? And also I have the velocity due to reflected wave is rho 0 C 0 sine theta r, but that is same as sine theta 0, but the direction has to be minus. Because the reflected wave is reflected in the other direction, okay? And that has to be same as pt over rho 1 c1 sine theta 1. Therefore, I can write that this is over sine theta 0. This is over sine theta 0. And this is over sine theta 1. And those results are exactly same as the result we obtained for the string that has a different characteristic impedance. The only difference is this. So when we have oblique incidence, the characteristic impedance is rho 0 C0 divided by sine theta 0. Okay? That we call what? Oblique impedance. So I can write the same, the PR over PI, that is the reflection coefficient, how much wave is reflected, and I can write that this is Z1 minus Z0, Z1. And the transmitted wave is simply, but where the impedance is rho over sine theta. Same expression. The only difference is this. Why? Because the way to excite the flat surface of discontinuity is related with the sine theta. So we traveled along the very long way, but our conclusion come back to this very well-known string case. So we're back to string case again. That's why you have to start with the simplest case. You true guys are not very happy, right? You consider me, I mean, you thought that I have been cheating you. But no cheating. Mathematical derivation introduced the only difference is this impedance. Result is the same. Okay.
I don't know why we multiply sine theta 0 and sine theta 1. I think cosine.
Cosine? Ah, that's a good question. Maybe you are right. Is it cosine in the text? I think when he had the homework, we have to put additional extra point for him. Sorry, this has to be cosine. I was wrong. Right. Thank you very much. Thank you very much. Okay. When we have this one, the transmission loss would be what?